So how do we find the place value? How do we round numbers? How do we estimate? Estimation, expanded notation. Those are all quick review items that will then lead us into the next topic, which is going to be adding, subtracting, multiplying, dividing. Before we do that, there's something in math called properties of real numbers. So we're going to have a discussion on these, but for now, I want you to just write it down in your notes, properties of real numbers. And I'm going to mention some of these properties to you. Number one, so when we talk about the properties of something, it's the way that thing behaves. And so what are some of the properties of real numbers? Well, the very first one that we're going to use is called the identity property. Let's start with the identity property. The identity property of multiplication. The identity property of multiplication. So the identity property of multiplication is saying that if you multiply a number like 5 times 1 is equal to 5. By the way, this is the same thing as writing that. It's the same thing. So 5 times 1 is 5. Now, somebody might ask, why would you need to say that? Well, when you're adding fractions and you get a common and you're trying to get a common denominator, this is what you're doing sometimes, is you're actually multiplying by 1. So I want you to know that even if it looks strange that we have to tell you this, there's a reason. And I'll tell you the reason now also. If you multiply 5 times 2 over 2, you will get 10 over 2. But that's the same thing as 5. But there are times when you want 10 over 2. So what you do is you multiply by 1, but this is the same thing as 1. That's what's going on over there. So the first property of real numbers is the identity property. Now we're going to do more properties. The next one we're going to do is, let's do the identity property of addition. If you add a number to 0, it doesn't change. Again, you're probably wondering, why are we talking about adding numbers to 0? Like, of course that's true. But, or the other word that we use for this, by the way, is the additive identity. Yes, it's true, but it might not be as straightforward as you think until you start doing upper level math, and you'll see why this is important. Now, I'm going to tell you a thing we do in math, which is when, if you have a letter instead of a number, it's to show generality, right? That's one of the reasons. What this means is that you can substitute anything for the letter and it's true in this case. What I mean is, instead of giving you, I can give you many more examples, right? Like I could say 6 plus 0 is 6. 7 plus 0 is 7, and on and on and on. So what we do is we introduce a letter sometimes to show that this is a general rule that you can always use. So we have the identity property of addition. So we have the identity property of multiplication, and we have the identity property of addition. The next one we have is the inverse property. So let's talk about the inverse property of addition. So the inverse property of addition says that a number plus its opposite is equal to 0. So for example, we're going to do 2 plus -2, which is equal to 0. So a number plus its opposite is equal to 0. I can write this down as a plus -a is equal to 0. That's also true. Doesn't matter what a is, this will always be true. Number 4. what about the multiplicative or the inverse property of multiplication? The inverse property of multiplication. So we're going to say the inverse property of multiplication. So the inverse property of multiplication says if you multiply a number times its reciprocal, that's something you might remember, reciprocal. So a number times its reciprocal is equal to 1. Okay, so that means that I could do like 15 times 1 over 15, that's equal to 1. So this is called the inverse property of multiplication. And the rule is also true such that I can use a letter and I get that as a general sort of understanding of that rule. So we have the inverse property of addition, the inverse property of multiplication, and now number 5, we're going to go with the zero product or zero property of multiplication. The zero property of multiplication. Okay, what that means is that if I multiply a number by 0, I get 0. If I multiply a number by 0, I get 0. And I can make this. Remember, this dot in the middle of this numbers is the same thing as saying multiplication. So, and there's a reason for that. It's partly because once you start getting into algebra and algebra, pre-algebra, algebra 1 concepts, you start using letters a lot, and we use the letter X, and we don't want to mix up the letter X with multiplication. That's one of the reasons that we use the dot, and it works out just fine. So I can do this as A times 0 is 0. Now, what I want you to do before tomorrow or Thursday is to write down these properties of numbers, properties of real numbers, and maybe write them somewhere. You can look them up online too, but try and make like flashcards. You can make flashcards, digital, paper flashcards would be great. Okay, we're almost done with these properties. Number 6. Number 6 is, let us do the commutative property of addition. Commutative property of addition. The commutative property of addition. So what it means here is that you can basically add things in any order and they will stay true. So if you add 3 plus 4, it's the same thing as 4 plus 3. That stays true. If you have 12 plus 7, it's 7 plus 12. That's true. This is 19. This is 19. Okay, now I can do it in the form of letters. 2 things added together will be the same, even if it's just the letters. So that's called the commutative property of addition. There's another one called the commutative property of multiplication. Again, I'll be able to give you this video. You can go back and see the different slides. For the commutative property of multiplication, okay, so for this one, what number are we on? Number 7. So for number 7, for the commutative property of multiplication, it just says if you multiply 2 things together, the order in which you multiply them doesn't matter. Notice that in this one is 4 times 2, this one is 2 times 4. So A times B is equal to B times A. That's the commutative property of multiplication. Number 8. We only have three more. The associated property of addition. The associative property of addition. So for this one, if you have 2 plus 3 plus 4, it is equal to 2 plus 3 plus 4, whether it's this way or this way. Because in this case, it's going to be 2 plus 7. In this case, it's going to be 5 plus 4. So then this is 9 is equal to 9. So that is the associative property of addition. You can associate these numbers in different ways. Now, if you want to do the associative property and the commutative property, you can actually bring that into this discussion. That'll be a fun project sometime. But let's write down number 8, the associative property of addition. Number 9 is going to be the associative property of multiplication. The associative property of multiplication. Okay, so in this case, it's going to be, if I have 2 times 3 times 4, like this, so then that becomes 2 times 12, this becomes 6 times 4, 24 is equal to 20. So that becomes the associative property of multiplication. And you can use A times B times C is equal to A times B times C. These is the letters representing that. Now the last one, I don't know that it's always this way in every textbook, but the last one is the distributive property. We're just going to add the distributive property. The distributive property, and it is involving multiplication. The distributive property. And so if you have a situation like 2 times 5 plus 6, and you want to use the distributive property, you say it's going to become 2 times 5 plus 2 times 6. So that's the distributive property. This becomes 10 plus 12, which is equal to 22. Now, you could have technically added these two things together to get 2 times 11, which is also 22. But this is why we use the distributive property. I'm just going to give you an example. Before I give you the example, let me give you the general rule. It's A into B plus C. So that's equal to A times B plus A times C.
Yes.
So it'll be A times B plus A times C. And so for this last one, I'm going to give you some numbers. I'm going to put 5 is into x plus 4. This will be the first introduction a little bit into more of that pre-algebra type problem. But the rule says you have to distribute, right? And so the number on the outside will multiply the things on the inside. So we have 5x plus 20. And that becomes the use of the distributive property. I'm going to stop here, take questions, and then we'll go from there.